Imagine yourself on an international flight in the midst of a devastating storm. The plane is being violently shaken. The passengers around you are terrified. The rain pounds against the window with such brutal force that you can barely see the runway lights below. The captain calmly announces, "We are about to begin the landing procedure." You think to yourself, how is this possible? How can the pilot land a 300-ton machine on a runway he can't even see clearly in conditions where the wind itself is trying to push the plane sideways? You would think that landing would be absolutely impossible. You would think that the plane should wait for the weather to improve, or perhaps be diverted to another airport. But no, the plane descends. It cuts through the clouds, and a few minutes later, you hear the sound of the tires touching the tarmac. The plane brakes with millimeter precision and stops safely on the runway. How is this possible? How do pilots manage to land planes in storms, in dense fog, in conditions where visibility is only a few meters? How does an airport manage to guide a machine weighing hundreds of tons with enough precision to land safely when no one can see anything? Today we're going to reveal this extraordinary secret that saves lives every day. You'll not only understand exactly how airplanes manage to land safely in adverse conditions, but you'll also see the sophisticated and precise engineering that connects wartime radar technology to a simple system of lights on the ground. There's a reason why airplanes are the safest mode of transportation there is, and you're about to find out why. Before modern landing systems, airplanes were completely dependent on one thing: sight. Pilots literally flew by what they could see. On cloudy days, flights were canceled. On dark nights, airports simply closed. Pilots relied on their eyes, their instincts, and visual cues in the terrain below. The number of accidents was extraordinary. Pilots lost in fog, crashed into mountains they didn't even know existed. Planes collided with obstacles because the pilot couldn't see radio towers or nearby buildings. Dark nights meant impossible landings. The aviation industry grew, but safety remained fundamentally limited by the human capacity to see. We needed something more. We needed a way to navigate and land that didn't depend on sight. We needed a way to chart a course through fog, rain, and total darkness. We needed a way to guide the airplane through adverse conditions with surgical precision. This urgent need led engineers and scientists to develop a series of systems that, together, transformed airplane landing from an act of faith into an act of mathematical precision. The solution wasn't a single invention. It was several inventions working in perfect harmony. And this engineering is so elegant that it would completely change how we understand aviation safety. The safe landing system in adverse conditions consists of 5 fundamental elements working in perfect synchronization. First, there's the Instrument Navigation System, known as ILS, or Instrument Landing System. The ILS does not rely on vision. It relies on radio waves and electronics. It works like this. On Tegro, near the airport, there are special transmitters that send radio signals in very specific patterns. One transmitter sends a signal that defines the horizontal alignment of the aircraft with the runway. Another transmitter sends a signal that defines the vertical alignment of the aircraft with the runway. These signals cover the entire airport approach region in an invisible cone of precision. The aircraft, through its radio receiver, receives these signals continuously as it descends. The signals are not messages in words. They are radio patterns that the aircraft's equipment interprets as positioning information. If the aircraft is too far to the left, it receives a different signal. If it is too high, it receives another different signal. The aircraft knows exactly where it is in relation to the runway, millimeter by millimeter, even though the pilot cannot see the runway through the fog. It's as if there were an invisible trail in the air, and the aircraft follows it with precision. This is the second element, automation. Modern commercial aircraft have such sophisticated autopilot systems that they can land the aircraft safely without any human intervention. The autopilot receives signals from the and continuously adjusts the aircraft's controls, keeping it perfectly aligned with the runway. Every fraction of a second, the aircraft makes small adjustments. If the wind is blowing from the left, the system compensates by turning to the right. If it climbs too high, it reduces the descent. If it descends too low, it increases the angle. Everything happens in real time, with a speed and precision that the human brain could not achieve. Many commercial aircraft can make a fully automatic landing with the pilot's hands off the controls in dense fog with complete safety. But there is a third crucial element: the terrain proximity warning system, known as GPWS. GPWS is basically a radar that maps the terrain below the aircraft. As the aircraft descends towards the runway, the GPWS system constantly checks for mountains, buildings, or any obstacles between the aircraft and the runway. If the system detects that the aircraft is descending too rapidly toward an obstacle, it emits a loud and clear alarm: "Descend the mountain." The pilot immediately knows something is wrong and can make a safe turn. GPWS has saved countless lives over the years, preventing collisions with terrain that would otherwise be invisible in the fog. But there's more. The fourth element is the special runway lighting system. Even if the aircraft is being guided by instruments, even if the pilot can't see anything, there are lights on the ground that help in the final moments of landing. These lights are not like normal street lights. They are extremely precise lights, arranged in very specific patterns. Approaching the runway, the aircraft passes through green lights. Closer, the lights become white. Very close, the lights become yellow. And if the aircraft is very low, they become red. It's a color-coding system that allows the pilot, when finally able to see the runway through the fog, to know exactly where they are in relation to the runway. But there is a fifth element that makes all this possible: the ground-to-air communication system. Air traffic control on the ground is in constant contact with the aircraft. They provide additional information. They report on wind conditions, atmospheric pressure, any changes in weather conditions. The pilot receives this information and makes further adjustments if necessary. Safety is it's not just one system, it's several systems working together, each checking the other, creating a safety network so dense that a safe landing becomes statistically guaranteed. But here's the big takeaway that most people don't understand. These systems were developed in an extraordinarily conservative way. Every innovation in aviation was made with redundancy in mind. If one system fails, another system takes over. If two systems fail, there is a third system. If three systems fail, there are still safety options. Historically, the first instrument landing systems were developed in the 1930s. Pilots began using radios for navigation, but it was extremely primitive. Later, during World War II, the systems improved significantly because bombers needed to fly in any weather conditions to reach their targets. The British developed a sophisticated system called Lorenz that allowed for more precise landings. After the war, the technology was adapted for civilian use. The modern ILS, the system you may be using today when taking off on a cloudy day, was developed in the 1950s and 60s. And since then, the technology has only improved. Today's systems are digital, extremely precise, with multiple redundancies and safety features that were unimaginable 50 years ago. A modern aircraft can land in fog so dense that the pilot cannot see the wings of his own plane. It can land safely in crosswinds of 70 kilometers per hour. It can land in torrential rain that would reduce visibility to just meters. It can land at night with zero visibility and land with an accuracy of only a few centimeters relative to the center of the runway. Although the technology has evolved extraordinarily over the decades, the fundamental principle remains the same as it was conceived in the 1950s. The plane follows an invisible radio signal. The computer maintains perfect alignment. Lights guide the last few meters, and the pilot, although not directly controlling the plane, remains attentive, continuously checking that everything is working correctly. Modern Boeing 777 and Airbus A380 aircraft are equipped with automatic landing systems that are triple redundant. If one system fails, the second system takes over. If the second system fails, the third system takes over. If all three systems fail, there are still manual controls available that the pilot can use. The probability of a safe landing is so high that statisticians have difficulty measuring it. Most air accidents occur during other phases of flight, not during landing. Pilots train hundreds of hours, including repeated simulations of landings in adverse conditions. When a pilot receives their commercial flight license, they have undergone dozens of landing simulations in fog and storm conditions. Their instincts are so well trained that even if all instruments failed, they could make an emergency landing. The next time you're on a flight, and the captain announces that we're about to begin the landing procedure in a storm, in dense fog, in conditions that seem impossible, remember that you are not taking any risks. You are being guided by such sophisticated engineering, by such precise safety systems, that a safe landing is practically guaranteed. The plane is being piloted by computers as intelligent as any engineer who designed them. It is being guided by invisible signals, as precise as a surgeon using a scalpel. It is being monitored by such attentive protection systems that any error would be detected instantly. The truth is that modern airplanes can land safely in conditions where it would be absolutely impossible for a car to drive on the road. Visibility can be zero. The wind can be blowing from all angles. The rain can be falling with devastating force. And yet, the plane descends, touches down with perfect precision, brachiocephaly, and you get out and walk to the terminal as if nothing extraordinary had happened. Because for you, it was an ordinary journey. For the engineering inside that plane, it was an exercise in precision that would make the old pilots of the 1930s look to the sky in absolute admiration. You enjoyed this revelation about how planes managed to land safely in adverse conditions. Did you like and subscribe to the channel? If you haven't already, now is the perfect time. Turn on notifications so you don't miss future videos like this one. And leave your comment below. Were you ever on a flight when the weather worsened? How did you feel, knowing that the landing would still be safe? Or was this your first time discovering how planes manage to land in fog? I want to know your stories. Share them with me in the comments. But before you go, click on the video that's appearing on your screen right now. In it, you'll discover another fascinating fact that you probably never wondered about. So click there, continue the journey with us, and let's unravel another mystery that surrounds you every day.